So, let's talk about something that drives pretty much anyone who uses generative AI completely nuts. It's wild, chaotic unpredictability. Today, we're going to break down some fascinating new research that actually uses an idea from quantum physics to explain this chaos, and it offers a whole new way to understand and maybe, just maybe, control it.
You know exactly what I'm talking about, right? You ask something like ChatGPT or Gemini for a simple definition, and boom, you get a perfect answer. But then you ask it again, maybe you change just one tiny word, and you get something totally different. Sometimes it's even just wrong. It's got to be one of the most maddening things about using these tools.
Well, what if I told you that this isn't a bug, that it's not a glitch to be fixed? According to some incredible new research, this unpredictability is actually baked right into how these AIs work. It's a core feature, a fundamental challenge that's tied to the model's hidden internal thought process.
Okay, so to get our heads around this, there's a key concept we need to know: the internal semantic state. Now that sounds complicated, but just think of it as everything that's swirling around inside the AI's head, all its knowledge, the context from your prompt, its so-called memories, in the split second before it gives you an answer. The big problem? This state is a total black box. We can't see it, we can't measure it, it's hidden.
And this is where things get really cool. The researchers behind this paper suggest that we can understand this AI chaos by borrowing a famous idea from a totally different world: quantum mechanics. I know it sounds a little out there, but stick with me, because it gives us a surprisingly clear way to think about why AI acts the way it does. They're calling it the AI uncertainty principle. And just like its famous cousin in physics, it's all about a fundamental trade-off. It basically says you can never ever know both the AI's exact internal train of thought and its exact final output at the same time with 100% certainty. The more you try to nail down one, the fuzzier and more unpredictable the other one gets. And this analogy just makes it all click into place. You know how in quantum physics you can't measure a particle's exact position and its exact momentum at the same time? Well, with generative AI, you can't know its internal state and predict its output perfectly. And get this, just like measuring a particle forces it to pick one reality out of many possibilities, your prompt forces the AI, which is holding tons of potential answers in its mind, to collapse all of them down into that one single response you see on your screen. So, it's a really neat theory, but does it actually work? I mean, does it hold up in the real world? Well, the researchers didn't just stop with the cool idea. They ran a whole bunch of experiments using the latest and greatest models. We're talking GPT-4o, Gemini 1.5 Pro, and Claude 3, to see if this principle was for real.
Their first test was pretty straightforward. If the theory is right, then a more specific prompt should kind of lock down the AI's internal state, right? And that should lead to a much more predictable, less chaotic answer. So they tested it, comparing really vague prompts like describe a place against super specific ones like describe the Eiffel Tower.
And wow, the results are crystal clear. On the left, with those vague prompts, you see a ton of output variability, or what scientists call entropy, a score of 8.74. But look what happens on the right when they use specific prompts. That variability plummets down to 8.09. That's a huge drop, and it confirms it. Being specific really does tame the chaos.
So the bottom line is clear as day. When you narrow down the AI's possible thoughts with a precise prompt, you get way less randomness in its answer. This is direct proof for the first part of the AI uncertainty principle. If you constrain that hidden internal state, the output becomes more predictable. The theory holds.
Okay, so that's step one. Being specific is good. But that leads to the next big question, right? Is more detail always better? The researchers decided to push this idea to its limits.
They started with simple prompts, then started adding more and more detail. And at first, it worked like a charm. As you can see here, going from a low complexity prompt to a medium one, the variability in the answers dropped like a rock, from over 8 all the way down to 6.8. So far so good. More detail seems to be the answer.
But then, something totally weird happened. When they kept adding complexity, overloading the prompt with tons of details and rules, the variability shot right back up again. The AI's answers actually got more chaotic, not less. It's a perfect U-shaped curve. And the takeaway here is just fascinating. It turns out there's a Goldilocks zone for how complex your prompt should be. You need enough detail to point the AI in the right direction, but if you give it too much information, you just overwhelm it, and you actually introduce more uncertainty and make its answers less predictable. All right, for the next test, the researchers decided to throw a curveball at the AI, something we all have to deal with every day: distractions. What happens when you stick information in a prompt that sounds plausible but is completely and utterly irrelevant to the actual question?
The result was, well, it was dramatic. Adding that irrelevant distractor info, like, say, asking about the American Civil War but throwing in a random fact about the French Revolution, caused the factual accuracy of the AI's answers to tank by an average of 25%. Just let that sink in for a second.
And this quote from the paper tells us exactly why. The AI doesn't just ignore the junk you throw in. Nope. It actively tries to weave that irrelevant info into its explanation, and that just messes everything up, making the answer less accurate and way more random. Okay, so that all sounds a little bit messy, right? We've got issues with specificity, complexity, and distractions. But here's the good news. This research doesn't just point out the problems. It actually gives us a kind of user manual for getting more reliable, trustworthy results. Now, one of the pro-level techniques they tested is called sigma-weighted aggregation. It sounds super technical, but the idea is actually pretty simple. You just ask several different AIs, or the same AI multiple times, the same question. Then you basically grade each answer on how reliable it seems, and you combine the best parts into one super answer. It's a great way to systematically filter out the nonsense.
And for the rest of us, for our everyday use, this whole study boils down to 4 golden rules for better prompts. Number 1, be specific. Number 2, find that Goldilocks sweet spot for complexity. Not too simple, not too crazy. Number 3, be a ruthless editor. Cut out all the fluff and irrelevant details. And finally, number 4, keep your language simple and direct. The data shows this leads to more stable results every time.
But this is way bigger than just helping you and me write better prompts. Understanding these deep principles is absolutely essential for the people who are actually building the next generation of AI. This is the roadmap to creating systems that are more predictable, more trustworthy, and more reliable for everyone.
And this really sums up the whole thing, doesn't it? The trade-off is real. If you want a predictable answer, you have to put in the work to control the AI's internal chaos with a sharp, specific, and clean prompt. But, and this is the big but, you also have to accept that you'll never get rid of the uncertainty completely. It's just a fundamental part of how these things work. It's a feature, not a bug.
You see, getting a handle on this AI uncertainty principle isn't about fixing the chaos. It's about learning to work with it. It's the first, most crucial step toward building AI systems that we can actually understand, manage, and ultimately trust with the important stuff.
And that really leaves us with a huge question for the future, doesn't it? As we weave AI deeper and deeper into our lives, into our medicine, our finances, everything, are we actually prepared to manage this built-in, fundamental chaos? Or are we going to keep demanding a level of perfect certainty that this technology, by its very nature, can never truly give us?